All right, so on this first slide, very good. All right, so it says a random survey of 10 students recorded their number of hours of activity each week and their body mass index, or BMI. The results are shown in the table below. It says which of the following best describes the data. So it's going to be linear, nonlinear, positive, negative correlation. That's an example of what it wants you to say when you want to describe it. So usually we're given a graph to find the correlation. What are we given this time? A table. We have a table. So what are we going to have to do with this table? So now we're going to have to plot the points. So either on a different sheet of paper or let me toggle screens real quick. Or on the side, you should have something that looks kind of similar like this. So notice I have this labeled as X and this labeled as Y. Typically the column that's on the left, that's your X axis. And then the column on the right, that's your Y axis. So you'll draw the graph, you'll graph it, and then you can label it as in multiples of 2 if you want. It's okay if you go off the grid, off the graph, that's okay. We're just trying to get a general idea of what correlation is giving us. So go ahead and take some time to graph that, and I'll come around and take a look. There you go. That's 2. The multiple of 2. All right, so looking at my screen, you should get something similar to this right here. What kind of correlation is this making, do you think? Downward. Yeah, so it's making a downward trend. So positive correlation would be something starting down here and going up. But since it's going downward, that means we have a what kind of trend or what kind of correlation? Negative, good. So with that, let's take a look at what answer choices they give us. So it says, based on what you wrote, which answer would you choose? It says, which of the following best describes the data? So which one would you guys choose? B. Yeah. Good. Yeah, B is in boy. So linear negative association, because we already established that it's a negative association. So you should get B. Yeah. Yes. You don't have answer choices on there, so you'll just have to write down what the correct answer is when you see it on my screen. All right, so the second one says, the scatter plot below shows movie theaters with different numbers of screens and their average weekly attendance. Based on the trend in the scatter plot, approximately how many people will be in attendance at the movie theater with 8 screens? And it asks, how did you determine your answer? All right, so 8 screens. Let me pull up the document camera real quick. Yeah. Yeah, I'll let you in. All right, so first of all, we need to find what's given to us. And what's given to us is 8 screens. So are screens on our x-axis or are they on our y-axis? They're on our x, yeah, number of screens. So that means we're trying to find where this trend line is going to land on 8. So we draw a line from 8, and we want to know where it's going to land on here. So now what we're going to do is we're going to use our patty paper to try to estimate and make a prediction where it's going to land on 8. So don't forget these 2 dots down here. So we're going to kind of go in the middle. Then kind of go like that. Yes. Yeah, you should be fine. If you want to use a ruler, you can borrow my ruler. It's up here if you want. Yeah. Oh, yeah. All right, there you go. All right, so I'm getting a little bit over 120. So a lot of people in previous classes were getting about 110. Now, if I'm at 110, it looks like it might be kind of in the middle right here, but then we're neglecting all of these scatter plots down here. So even if we move a little bit to come down here, then it's not representing a middle point between these ones up here. So we would have to move up a little bit. So it's going to be around a little bit over 120. So with that, we're going to go back to the slides. Based on what you wrote, which answer would you choose? So I got a little bit over a 120, so it's going to be 120. So that's the closest estimate to 1. So it'll be C. All right, so this next one, it says Oscar did a research project about the use of sunscreen and the number of freckles a person has. Before he did the project, he predicted that the more sunscreen a person used, so the more sunscreen you use, is that positive or is that negative? Is that moving up or moving down? Positive. And then with that, the fewer freckles you would have. So fewer, what does that indicate? Negative. Negative, going down. So the scatter plot below shows the result of his research. Did the research support his prediction? Yes or no? No, because let's move to the document camera real quick. All right, so number 3. Let's make some examples here. Some example graphs. This is freckles. Sunscreen. All right, so first off, that's making kind of just a straight line, a horizontal line. So is this showing us a positive or negative correlation? No. It's showing us a trend. It's going just in a straight line, but there's no correlation. So sunscreen and freckles don't relate to each other in any way. So what we want to get is what Oscar is predicting. So if we have scatter plots that look like this, that's down and that's up. First off, is sunscreen increasing or decreasing in this first graph? The sunscreen's increasing. What about the freckles? The freckles? Yeah, the freckles are decreasing. And then the second one right here, the sunscreen is increasing and the freckles are also increasing. So this is a positive correlation. This one would be a negative correlation. Now remember, it says the more sunscreen a person used, the fewer freckles. So that means it would be a negative correlation. So that means Oscar is predicting that this one right here is the graph. But what's presented to us? Is that what's presented to us, a negative correlation? No. So it's asking, did the research support his project? It would be no. So let's take a look at what the answer choices give us. All right, so we can automatically go ahead and eliminate which ones? B and C. So go ahead and we'll eliminate B and C because those ones say yes, but we already know the answer is going to be no. So we just need to look at A and we need to look at D. So the first one, A, says no because his prediction was a negative correlation and the results show no correlation. So the no correlation part is right. What about the negative correlation? Did his show negative correlation? That first graph that we agreed on? Let me go back to it real quick. This one right here, is this a negative correlation? Yep. And that's what's in this one right here. So it should be A. But let's take a look at D just so we can use process of elimination. So it says no because his prediction was a positive correlation. Do we say his prediction was positive? No, his prediction was negative. So you should get A in this case. So it'd be no because his prediction was a negative correlation and the results show no correlation. All right, so looking at number 4, it says, for a science project, Natasha counted fireflies each evening. She also recorded the temperature in degrees Fahrenheit. The data for both the number of fireflies and the temperature are recorded on the graph below. It says, based on the graph, predict the range of fireflies Natasha might see when the temperature is 100 degrees. Explain how you got your answer. All right, so it wants us to predict how many fireflies when the temperature is 100. First of all, when we make our line, we need to find 100 degrees. Are we going to do that on the y-axis or on the x-axis? So first we need to find 100 degrees. So where is degrees at on the x-axis? Or on the, it's on the, I just said it. It's on the x or on the y? Temperature, degrees. Yeah, it's on the x. That means, let me pull up the document camera. Yeah. Yeah, go ahead. Oh, careful. All right, temperature of 100. So that means we're going to come right here, 100 on the x-axis. Thank you. All right, so here's 100. That means we're going to, from 100, we're going to draw our line. And we want to know where this trend line right here is going to land somewhere up here. So we want to know how much that is in fireflies, which is going to be somewhere up here. So let's go ahead and make our trend line. I'm getting something like this. So maybe about like right here. Good. So what number is that about? 19? Okay. Let's take a look and see what answer choices they give us. So which one do you think it'll be?
It'll be B.
B, yes. That would be correct. All right, let's look at number 5. So it says the scatter plot below shows the number of pages printed for various numbers of minutes at Copies R Us. Predict the number of minutes it would take to print 10 pages. Explain how you got your answer. All right, so which figure is given to us and what unit?
What?
Which figure in unit is given to us?
Minutes and page numbers, like pages printed and number of pages.
Yeah, I'm talking about in the question. What's given to us? 10 pages. So we're looking for how many minutes. So our answer is going to be minutes. So we're looking for how many minutes with 10 pages. So that means we're going to find 10 on the x-axis or on the y-axis. For pages? Which one's pages on?
X, Y.
This is x-axis. So where is pages at? On the y. So let's pull up the document camera. So 10 pages. So 10 pages is where it's right here, so about right here. So that means we're going to draw our line. This time it's going to be horizontal. And we're trying to find how many minutes does it land somewhere in here, right? So let's go ahead and put on our, whatchamacallit, patty paper. So I would say about right here. So it lands about right here. So maybe just a tad over 3 or maybe about 3. No. So well, we have a grade tomorrow for the test. Tomorrow.
Really?
Yeah.
For what?
Over Scatterplots. Yes. Gotta look at the agenda, guys.
Wait, what did we get? I'm gonna try to. I don't even know what zebras was the thing. I don't even know what we're talking about.
Well, come to tutorials then.
What is tutorial?
Mondays and Wednesdays after school.
After school?
Mm-hmm.
And Wednesday? What answer?
Mondays and Wednesday, yeah. All right, so back to this. All right, so based on what you wrote, which answer would you choose? All right, so which one did you say? B, yeah. So let's go back to the let's go back to this real quick. So on here, so we did our horizontal line this time to land on 10. So now we need to know how much it lands on when it's right here, which we said is 3. So our answer choice, our closest one, is going to be B.
36.
Yeah, so you can automatically eliminate 34 and 36, automatically eliminate A and C. And that'll leave you with B and D, and that'll give you a 50% chance of getting the right answer. All right, so taking a look at number 6, it says the costs of shipping packages of varying sizes that weigh up to 40 pounds are shown below. And it says Maxine made the following statements about the data shown. So 1 through 4, and it says which of the following statements, there might be more than one, that Maxine made about the data are true. So we're looking for which statements are true. So you got to go through each one of those Roman numerals and see which statement is true. So let's take a look at it. Let me pull up the document camera. All right, the first one, it says the more a package weighs, the greater the cost to ship it. So that's saying whenever there's an increase in package weight, there's an increase in the cost to ship it. So an increase in X values causes a Y to increase. That's a positive or negative correlation. You have an increase and increase. A positive, yeah. Do we have a positive correlation? We do. So we're going to go ahead and put a check mark if that's true. All right, the second one says the less a package weighs, the cheaper the cost to ship it. So if we have, let's go to the smallest one. This looks like it might be the smallest one. It says the less a package weighs. So this is the smallest one, the smallest weight, the cheaper the cost to ship it. So cost is going to be over here on this side. Is this one cheaper than all the other ones over here? Yeah, so that would be a true statement. All right, the data shows a positive linear correlation. We already established it's a positive correlation, so that's true. And then it says it would cost between $10 and $15 to ship an 8-pound package. So 10 to 15, so let's find 10 to 15, which is between this little square right here probably, and then 8-pound package. Where's 8 land at? About right here. So we need to get our patty paper, find our middle ground. Let's say that's about middle. So it lands right here. So is that in between 10 and 15? Yep. So that'd be a true statement as well. So all of them are true. So let's take a look at our answer choices. So which answer choice would it be?
D.
D, yeah, all the statements are true. All right, so number 7. The scatter plot shows the relationship between the distance that students travel to get to school and the number of times those students were tardy during the school year. So we're looking at a correlation, if there's a correlation, between number of tardies and distance traveled to school. All right, so it says the principal of the school wants to use this information to help him determine if there is a correlation between distance traveled and the number of times tardy. So now the important part, if you were the principal, what would you say about the data? So what do you guys think about this data? What does this data look like to you?
It's scattered.
It's nonlinear, yeah, so it's not a straight line, it's scattered. So if it's scattered, is there a correlation? There's no correlation. So let's take a look at what the answer choices give us. All right, so the first one says, the student who travels 1.5 miles to get to school will be tardy 9 times during the school year. What do you guys think? No, we don't know because there's no correlation. So how can we make a prediction if there's no correlation? So if they're trying to make a prediction, we can automatically eliminate that one. So let's take a look at the second one. B says a student who travels more than 3 miles to get to school, we don't even have to keep going because they're making another prediction. So we can't use that one either. So we can automatically eliminate A and B. All right, C says there is a nonlinear correlation between, we can stop right there because it says nonlinear correlation. Now it's true that it's nonlinear, it's not a straight line, but we already established that there's no correlation. So we can automatically stop right there. It says it's a correlation, so we can eliminate that one. We have no correlation. All right, so D says there is no correlation between the distance the student travels to get to school and the number of times the student will be tardy during the school. Yep, that's what we just said. There's no correlation between the data. That's what the data on the graph says. There's no correlation. They're all scattered. So the answer would be what?
D.
D, as in delta, yeah. All right, so last one. It says the following scatter plot represents the number of negative consumer reviews for a given model of cell phone and the total number of that same cell phone model that were sold. Is it reasonable to predict that if there are 75 negative reviews, the number of cell phones sold of that same model will be close to 850,000? Why or why not? So they're basically making a prediction. So we need to take a look at it. And take a look at the graph. Let me pull up the document camera. All right, so they're claiming at 75 negative reviews. So negative reviews are negative reviews on the y-axis or are they on the x-axis? On the x, right here. So 75. So we're going to put our line vertical this time. And oh great, the trend line's already given to us. And where does it intersect? Right here. At how many cell phone calls? 600 or 600,000. So they're claiming that at 75 negative reviews, the amount of cell phones sold is 850. Is that a true statement? No. So the answer would be no. They at 75 reviews or negative reviews, they sell 600,000. I don't think this one has any answer choices. Yeah, this one's just share the answers and discuss. So yeah, so we said no, at 75 reviews, they sell 600,000. So that one's a false statement. All right, are there any questions on that?
Nope.
All right, I'm gonna go ahead and end this.